Hey guys, how's it going? I hope you're having a fantastic day. Um, Again, we're looking at chain rule with trig functions here. So a couple of things I wanted to point out. If you'll remember in class today, we kind of talked about, we did one question where we actually went through and did a trig question, a trig problem. So we're going to go through and do a couple of these here real quick. It says find the derivative using the chain rule. So again, the outside first, I would rewrite this as sine of x squared. So the outside, if you remember our M&Ms, the candy on the outside is the, oops, let me do it up here, is the square. So the derivative of that would be 2 and a power of 1. And the inside is a sine of x. Now this one we can go ahead and just do sine x because technically, even though an x is an inside, kind of like the peanut, it's a 1x, so I can just leave it as sine x. I know the derivative of that is cosine x, so I'm okay just to go ahead and throw that out there. So the chain rule then is going to be y prime is equal to, we've got a 2 and a parentheses, so it's 2, remember the inside doesn't change, so that's still going to be 2 sine x, and then drop your 1 down here, so it's power of 1 times cosine x. Now there was a nifty little thing in pre-cal that we learned. This was one of your, let me actually show you, this is your notes from last year. One of your trig identities is a double angle identity. It says that 2 sine A cosine A is sine 2A. So I can actually simplify that. 2 sine A cosine A, right? 2 sine A cosine A. In this case, A is x. And I can just call that sine of 2A. I know that you don't have these anymore. I will be giving one to you here shortly. All right. On the outside of the next one here, 2 tangent of 4x. So again, the 4x here is going to be the inside. So we've got the outside is 2 tangent, parentheses. The inside is the 4x. So take the derivative of that. You end up with,
Corey
really?
Dorsey, if you're in the building, please come to the front office. Corey Dorsey, if you're in the building, please come to the front office.
There's never a dull moment around here. 2 secant squared of something. Derivative of 4x is 4. So y prime is going to be 2 secant squared parentheses, and what's inside the parentheses doesn't change, remember, 4x times the derivative of the inside, which is 4. So that's going to simplify to be 8 secant squared of 4x. All right. So moving on here, let's actually do some of these. It says find the derivative of f of x equals 3 sine x squared plus x. So again, I'm going to set this thing up. And I'm going to find the outside, which is the shell here. So I've got a 3 sine parentheses. And then the inside, go one equation in, and you're at x squared plus x. And see, if there was another layer, I could go one more equation in, and I would do that extra layer. But I'm done here, so I can just keep going. The derivative then is going to be 3 times cosine of parentheses. And remember, your chocolate inside hasn't changed, so that's still x squared plus x, times the derivative of this guy, which is 2x plus 1. So f prime of x is going to be 3 cosine x squared plus x times 2x plus 1. And you can rewrite that if you would like. 3 and 2x there can be combined. You can reword it, rewrite it, however you want to do. Technically, this isn't wrong. Is it as simple as it could be? No, you could distribute the 3 to the 2x plus 1 But I mean, really, why? It's really not going to simplify anymore, so let's just leave it alone. All right, number 2 is one that's very, very similar to what we did in class today when we were doing the M&M question with the peanut. 2 is very similar to that. So let's go ahead and get some of this going here. So I'm going to set this up. First and foremost, the outside is, let's rewrite this, 1 over 6 times cosine 3x squared. So the outside is going to be 1 over 6 parentheses squared. The next level is cosine x, or cosine parentheses rather. And the next level is the 3x. So this one's got candy coating, chocolate, and a peanut. Again, we start outside, move our way inside, move our way inside. And let's derive that dude. Bring down a 2. 2 times 1/6 is 1/3. Chocolate and the peanut stay the same. Cosine of 3x. And that's power of 1 now. Times the derivative of cosine is negative sine. Peanut stays the same because we're working on chocolate now. Then we crunch through to the peanut. Derivative of 3x is 3. So f prime of x is going to be negative cosine, or well, let me see this, I'm sorry, 1/3, not negative, 1/3, what was I thinking? 1/3 cosine of 3x times negative sine 3x times 3. 3 times 1/3 will be 1, and then you can bring your negative out, so it'll be f prime of x is equal to 1, and then the negative on the sign will be negative cosine 3x times sine 3x. There is a way you can simplify this farther. I will cover that with you later, but for right now, I'm just going to leave it as it stands. But there is a way to simplify this farther, and I really don't think we need to get into it. I will show you how to do that at a later date, though. Okay? Example 3, trucking right along. It says, write the equation of the tangent line. Ooh, good. So we know tangent line means I'm going to need to have a y minus y1 equals m times x minus x1. My setup needs to be a line. I know I'm going to need a point, and I know I'm going to need a slope. So let's start working on some of this stuff here first. A point, they tell me x is pi over 6. So let's go ahead and plug that guy in for x. So y is equal to sine of pi over 6 plus cosine of, 2 pi over 6, since we're multiplying by 2. All right, so that's going to be, what, pi over 3? The sine of pi over 6 is 1/2 from the unit circle. The cosine of pi over 3 is also 1/2 from the unit circle. 1/2 plus 1/2 is 1. So the point is pi over 6, comma 1. Pause the video if you need to slow down a bit. Then I'm going to find the derivative, f prime of x. So sine of x is pretty simple to find, the derivative of sine x, but you also need to find the derivative of cosine of 2x. Now that's going to take a chain rule, because now I've got a function on the inside of cosine. I've got a 2x. It's not just an x anymore. Okay? So what I'm going to do here, I'm going to set up my chain. I've got cosine and I've got 2x. Cosine's my outer candy, 2x is my chocolate. Derivative of cosine is negative sine of 2x, because the chocolate hadn't changed yet. Derivative of 2x is 2. So you multiply them together, you get a negative 2 sine 2x. There's your M&M. f prime of x then is going to be the derivative of sine x. So it's going to be cosine of x plus, let me separate this here, the derivative of cosine 2x, which is this guy, negative 2 sine 2x. And then that's your derivative. Now all you need to do is figure out what the slope is at this x value. So f prime of pi over 6 is cosine of pi over 6 minus 2 times sine of pi over 3. If you do 2 times pi over 6, right? So from here, that's going to be square root of 3 over 2 minus 2 square root of 3 over 2. The sine of pi over 3 is the square root of 3 over 2, and then you're multiplying by 2. Now don't cancel these out just yet because you're still combining fractions and you're going to need them common denominators. So this is going to be 1 square root of 3 minus 2 square root of 3 is negative 1 square root of 3 over 2. And that is f prime of pi over 6. So your equation of the tan line is going to be y minus y1, which is 1, equals m, negative square root of 3 over 2, x minus x1, pi over 6. Alright, I know this may seem a bit rushed, but I am going to try and get this done as fast as possible so I don't have to spend too much time here and I can get this posted to you. Example 4 says find the derivative of y equals sine of 1 plus tangent 2x. Okay, this one is definitely going to be a peanut. Alright? It says find the derivative. So I've got sine of. Now this is not sine times. If this was sine of something times this, I'd have a product rule. But this is sine of this, so I have a chain rule. So my first layer is sine of something. My second layer, the chocolate, is 1 plus tangent of something. And the third layer is 2x. So you see we got a layer of sine of something, 1 plus tangent of something, and 2x. So the derivative of sine, just knock them out. Derivative of sine is cosine. Chocolate and the nut stay the same. 1 plus tangent 2x. Derivative of the chocolate, 1 plus tangent. Derivative of 1 is 0, so that goes away. Derivative of tangent is secant squared. The nut stays the same. And the derivative of the nut is 2. So y prime, very simple here. Multiply all these together. Your 2, if you want to, can go ahead and move out front. 2 cosine of 1 plus tangent 2x times secant squared of 2x. Not horrible, is it? Again, you may be able to simplify that at a later time. We certainly can try. We're not going to now, just for the fact that I don't think we need to. But we will go over some simplifying stuff a little bit later if we have time. I don't think it's going to be a skill that's going to kill you if you get caught up on simplifying. So example 5, evaluate the derivative of f of x equals the square root of sine 2x. Ooh, this one's going to be fun. Evaluate the derivative at x equals pi over 4. So they're giving me an x value and going to want me to find the derivative when x is this. So let's set it up. First, this is sine of 2x to the 1/2 power. So let's do this. I've got a layer that's a power of 1/2. If you ever don't know how many layers you have, just start on the outside, work your way in. I've got a sine layer. I've got a 2x, and then I'm done. So I've got 3 layers. This is a peanut question. 1/2, parentheses. The chocolate and the nut have not changed to the negative 1/2, right? This will be cosine. The nut has not changed, and the nut is 2. Multiply your 2 and your 1/2, so it gives you 1. So what you're left with here, good night, f prime of x is going to be, this is going to be in the bottom part of a fraction because of the negative, so let's just go ahead and jump to it. Cosine of 2x over sine of 2x to the 1/2. You could also do square root if you wanted to. And then they want me to find f prime of pi over 4. So that's going to be the cosine of 2 pi over 4, 2 times pi over 4, divided by the sine of 2 times pi over 4 to the 1/2 power. So that's going to end up giving you the cosine of 2 over 4 is 1/2, so pi over 2, the cosine of pi over 2 on your unit circle, the x value at pi over 2. Well, that's just going to be 0, isn't it? Now down here, the sine value at pi over 2 is 1. So you're left with the square root of 1. Or 1 to the 1/2 power, however you want to look at it. Either way, it's 0. Hot dog. Okay? Last one. Ooh, everybody's favorite. Given that g of 2 is this, g prime of 2 is this, h of 2 is this, h prime of 2 is this, and h prime of negative 2 is this, and f of x is h of g of x, find f prime of 2. What? Like what? So starting off here, we're starting with f of x, right? So let's set this up. Same way with the chain rule because we got one inside the other. It starts out with the outside, which happens to be h of something, right? And then the inside happens to be g of x. So what's the derivative of h? So f prime down here. The derivative of h is h prime. Chocolate has stayed the same, it's g of x, times the derivative of g of x. So this isn't going to be that crazy. Let's set it up. F prime of x is equal to h prime of g of x times g prime of x. If anything, this is even going to be simpler because they want you to find f prime of 2. So that's going to be, plug in a 2 everywhere. H prime of g of 2 times g prime of 2. Well, that's going to be h prime, and g of 2 is negative 2, so that's h prime of negative 2. G prime of 2 is 4 times 4. H prime of negative 2 is 7. 7 times 4. 28. Not too shabby, is it? So hopefully this will be a lot easier after what we did in class today. Hopefully it's starting to flow a little bit better. Just keep remembering about your candy coating, your chocolate, and your nut. All right? Have a fantastic day.